is bittersweet here.
What is a function? Let's try to simplify this concept, but instead of telling you what is a function, I'm telling you what it does. A function takes a value of its domain, which is all the numbers or elements that can be plugged into the function, and it will yield exactly one and only one value or element as the result of the evaluation. Now that we have an idea of how a function works, let's talk about their notation. We no longer will use the y is equal to something. Instead, we will write our functions as f of x, or g of x, or h of x. Well, I think you get the idea. In these examples, f, g, and h are the names of the functions, and x represents the elements of their domain, meaning x represents all the elements that can be plugged into the function. This notation is very useful because we can easily represent the value of the function at certain element of its domain. But let me show you what I'm talking about.
Graba poquito, graba muchito, pero graba algo porque ya es tardecito.
Well, meet f of x. This function is equal to x squared plus 2x minus 5. And from this text, this instruction, we know that we have to evaluate this function when x is at 3. But what is the meaning of that? This means that we're going to calculate the exact value of the range, which, by the way, is the set of the possible results of this function when x is at 3. And to do so, we just have to substitute this number 3 every time we find an x in our function. Okay guys, let's evaluate this function. See, as I mentioned before, I just changed every x by the number 3. That's why we have f of 3 is equal to 3 to the second power plus 2 times 3 minus 5. Instead of writing down all the x's, I substitute the value of the x, which in this case is 3. Let's continue with this process. F of 3 is equal to 9 plus 6 minus 5. The result of this evaluation, f of 3, is equal to 10, and that's the solution for this problem. Do you see something strange in this one? Well, think again. It is not that unusual that we evaluate algebraic expressions in functions. Remember that you just need to change the x's for whatever is on the parentheses on the left. Like this particular case, we're going to substitute x plus 2 every time that we have an x in our function.
Cause I'm happy, clap along if you feel.
Okay, like we say in Mexico. Vamos a darle que esto es mole de olla. Now that we substitute each one of these x's by x plus 2, we're going to use algebra to simplify this function. We have g of x plus 2 is equal to x plus 2 to the second power minus 2 times x plus 2. We have a special product in this part, which is the square of a sum. And to solve that, we have to square the first term. That's why I have x squared in this part. Then we are going to multiply 2 times the first term by the second term. That's why I have 4x in this part. 2 times x is equal to 2x times 2 is equal to 4x. Now I'm going to multiply each one of the elements inside of the parentheses by this negative 2. That's why I have negative 2x, because that's the result of the product of negative 2 and x. And in this part, this negative 4 is the result of the multiplication of 2 and negative 2. Now we're going to simplify similar terms. The first one is the x squared. I don't have any other term that includes the x squared. That's why I'm just passing this element like that. X squared is the first part of my solution. But in this other part, I have 4x and I have a negative 2x. 4x minus 2x is equal to 2x. And for the last element, I have a positive 4 and a negative 4. These two are going to cancel each other out, so I'm not going to write any other element. That's pretty much my solution. So the answer for this exercise, g of x plus 2, is equal to x squared plus 2x.
Por fin, prende el ventilador. Ya voy a empezar a hacer puros videos de voiceover. Por favor, que me conozcan como soy.
For the last exercise, we're going to evaluate the expression square root of x minus 3 times x into the function f of x is equal to 2 times x to the second power plus 4x. This means that every time I have an x in this function, I'm going to substitute this expression. And for this exercise, I'm going to change the square root of x by its fractional exponent notation, which is x to the 1/2 power. This means that every time I find an x in this function, the function m of x, I'm going to change those elements by x to the 1/2 power minus 3 times x. That's why I have in this part 2 times x to the 1/2 power minus 3x. These two elements are raised to the second power, and I'm going to sum the result of the multiplication of 4 and x to the 1/2 power minus 3x. I have a special product in this part. I have the square of a subtraction. I'm going to first work with this part, and when I get the result, I'm going to go back to this process. All right? Let's continue, shall we? So we have x to the 1/2 power minus 3x, and all of this is raised to the second power, and this is equal to the first term, which is x to the 1/2 power to the second power, plus 2 times this same term, the first one, times the second term, which is negative 3x, plus the second term, which is negative 3x to the second power. Now with this one, I have x to the 1/2, and this was raised to the second power. And when this happens, I'm going to multiply this exponent by the exponent of the x. That's why I have x to the 1/2 times 2. See? The exponent of the x is multiplying the power of this operation.
Do it again. ¡Cucaracha! ¡Qué asco, qué asco, qué asco, qué asco! ¿Por qué no te vas, cucaracha? ¿Tú también quieres aprender cálculo? ¡Qué inteligente! Más cucarachas como tú en el mundo deberían de haber.
Now, in the second part, I have a multiplication of 3 elements. So I'm going to start by multiplying the coefficients. 2 times 1 is 2, times negative 3 is negative 6. Now for the variables, I usually add up the exponents of the variables when they have the same base. But for this exercise, I'm going to leave my multiplication just like this because I want the simplest version for my result. So that's why I have x to the 1/2 power times x. And for the last part of this result, I'm going to raise negative 3x to the second power, which is the same as 9 times x to the second power. I'm going to multiply these two elements right here, leaving me with an x to the 2/2 power. I'm going to simplify this in the last part of my result. If I multiply this exponent, this is equal to 1. That's why I just have an x in this part. And I'm going to change the fractional exponent notation of this element by the square notation. That's why I have minus 6x times the square root of x. And this element, I'm just going to leave it like that. So the result of raising x to the 1/2 power minus 3x to the 2nd power is x minus 6x square root of x plus 9 times x to the 2nd power.
Too many x's. Pretty. Ay, Diosito, no salgo para no morirme de COVID y me llenas de mosquitos para que me muera de dengue hemorrágico. En fin, la hipotenusa.
So in this part of the process, I changed the fractional exponent notation by the regular square root that we all love and know. And that's why I have m of square root of x minus 3x. So I multiply this 2 by each one of the elements that I have inside of this parenthesis. 2 times x is 2x, 2 times negative 6x square root of x is negative 12x square root of x. And 2 times 9x squared is the same as 18x squared. Then I multiply the 4 by each one of the elements of this other parenthesis. That's why I have 4 times x to the 1/2 power is the same as 4x to the 1/2 power. And 4 times negative 3x is the same as negative 12x. Ready? So that's pretty much the development of this process. Now, the last thing that I'm going to do is to simplify all the elements of the resultant function. In this case, I'm going to start with the 18x squared. I notice that there's no other element that includes the x squared, so that's my first part of the result. Moving on with the x's, I have a 2x in this part and I have a negative 12x in this other part. If I simplify these two elements, I'm going to obtain as the result negative 10x. Well, I don't have any other element that includes the x and the square root of x as part of the term. So that means that I'm going to write it just like that in the answer. Last but not least is this 4x to the 1/2 power. And because I don't have any other element in the function that includes the x to the 1/2 power, I'm going to pass this element directly into my answer, but I'm going to change the fractional exponent notation by the square root notation. That's why I have a 4 times square root of x. And this is my answer, guys. This is the result of evaluating the square root of x minus 3 times x into the function m of x.
It's been a perfect journey time, baby.